So here's the first page for the Chapter 12 practice test. The directions say, find a positive and negative coterminal angle for each given angle. Draw the angles in the same coordinate plane and state which quadrant they terminate in. Coterminal means that they're going to end at the same spot. So if you draw a coordinate plane and you draw an angle that's 195 degrees, that's just after 180. So if here's 90, 180, 195 is going to be right about there. There's your 195. That is quadrant 3. And we write 3 with a Roman numeral. We need 2 more angles, one that's positive and one that's negative. So the negative one goes right here. So if we start with 190, if we start with 360 and we subtract 195, we get 165, and then we just make it negative. So this is negative 165 degrees. There's our negative one. To get the positive one, we start at the same spot we did here. We go around a full 360 and then another 195, whoops, all the way to there. So 360 plus 195, that one should be 555 degrees. All right, number 3, this one is negative 390 degrees. So if you draw your X and Y axis, the negative 390 degrees. So we're going to go a full negative 360 and then just a little bit more. So right here is your negative 390. That's quadrant 4. And we need 2 angles that end in the same spot that are coterminal. So if we go one right next to it, it's just that much. So if you start with negative 390 and add 360, you actually end up with negative 30 degrees. So there's a negative one. And then if you take the negative 30 and add another 360, you should get to 330. So there's a positive one. So that would be 330. So let's go this way. 330. Jumping down to number 5, the directions say, use the given point on the terminal side of angle theta to find the values of all 6 trigonometric functions. And so this point 3, negative 7, first you have to figure out which quadrant it's in. Because this is positive and this is negative, that means it's going to end up in quadrant 4. So I'm going to draw quadrant 4 over here. And I'm going to put a point at 3, negative 7. So it would be about right there. 3, negative square root 7. That means that you're going to go 3 units this way and down negative square root of 7 this way. And that creates your right triangle. So on a right triangle, if you know the 2 legs, you can get the hypotenuse by using the Pythagorean Theorem. So I'll call this C for right now, and I'll say C squared equals 3 squared plus negative square roots of 7 squared. And then I just simplify. 3 squared is 9. And this looks really complicated, but negative square roots of 7 squared is just 7. 9 plus 7 is 16. And if we square root both sides, we get C equals 4. So the hypotenuse over here is 4. Your angle theta is right here next to the origin. So from there, we need the sine, which is opposite over hypotenuse. So from here, opposite is negative square roots of 7 over the hypotenuse 4. The cosecant is going to be the reciprocal of that. So we're going to write negative 4 over the square root of 7. But you can't have a square root in the denominator, so you need to multiply by the square root of 7 over the square root of 7, which is equal to negative 4 square roots of 7 over 7. Now let's do the cosine. Cosine is adjacent over hypotenuse, so it's going to be 3 over 4. And then when we go to get the secant, we're just going to get the reciprocal, which is 4 over 3. Now let's do the tangent. Tangent is opposite over adjacent, so opposite over adjacent, so negative square roots of 7 over 3, which is fine. But when we go to get the cotangent, we're going to have the radical in the denominator. So we're going to need to multiply the numerator and the denominator both by the square root of 7, which gets you negative 3 square roots of 7 over 7. Sorry, running out of room. All right, should have made more space there. Number 7, solve each triangle. Solve means to get all 3 angles and all 3 sides. Round your answer to the nearest tenth if you need to, okay? So on this triangle right here, we've got angle A, which is 62 degrees, angle C, which is 90 because it has the little box. So to get angle B, we're just going to start with 180, subtract the 90 that we know, subtract the 62 that we know, and that means that angle B is 28 degrees. So we have all 3 angles. Now we just need all 3 sides, okay? So we've got one side. Let's call this side over here X and this side over here Y. So we'll solve for X first. So from angle A right here, we know the opposite and we want the adjacent. So opposite and adjacent is tangent. So we're going to say the tangent of 62 degrees is equal to the 7 over the X. Multiply both sides by X. Divide both sides by the tangent of 62. Got some canceling. So for the calculator, we're going to type 7 divided by the tangent of 62, which means that X is approximately equal to 3.7. Now we have 2 sides. And the last side we need is Y. That's the hypotenuse. So we're going to use opposite in the hypotenuse, which is sine. So the sine of 62 is equal to the opposite, which is 7, over the hypotenuse, which is Y. Multiply both sides by Y. Divide both sides by the sine of 62. And do some canceling. So for the calculator, you're going to type Y divided by the sine of 62. And it should give you roughly 7.9. And now you have all 3 sides. And your triangle is solved. So you need all 3 angles, all 3 sides. Jumping down to number 9. For number 9, we know 2 of the angles, so to get the third angle, you're going to say angle A is going to be equal to 180 minus the 90 of the box minus the 70. So angle A is 20 degrees, and you have all 3 angles. Now we just need all 3 sides. So let's call this one little letter A and this one little letter C. From this angle right here, we're going to do opposite and adjacent. So we're going to use tangent of 70 equals 11 over A. Multiply both sides by A. Divide both sides by the tangent of 70. Type it into the calculator. And I got A is roughly 4. Now we just need C, which is the hypotenuse. So we're going to use sine of 70 equals the opposite, which is 11, over the hypotenuse, which is C. So multiply both sides by C. Divide both sides by the sine of 70. And cancel away. Type in 11 divided by the sine of 70 on your calculator. And I got 11.7.